Welcome back, guys. Today we are going to explore another crucial component of production AI systems. It is nothing but load balancing. Specifically, we will dive into a certain token-based load balancer, which is again a custom policy that we have implemented. So we all know that load balancer is a critical policy, right? That distributes any incoming inference request across multiple block replicas, right? So this will make sure that we are utilizing the resources in an efficient way, and it will also make sure high availability and optimizing the performance and all. I will come back to this block diagram towards the end, but let me first give an overview about where we are in the AIOS ecosystem. Actually, let me open this image. Yeah. So here you are seeing this is the overall AIOS ecosystems high-level architecture. Here you can see this area, right? This is where we are in currently. Right here, we are talking about load balancing for the blocks as part of a block. We are talking about a blocks load balancer, so that the blocks can be, as per its scaling, the load can be distributed, right? And for more information related to the block, what is a block in AIOS, and for understanding more about the load balancer concepts, I request you to check these two documentations, especially the block concepts here, right? So if you are coming to this tutorial as the first point, then if this is your starting point for the AIOS ecosystem, then I will recommend you to check this particular block documentation. And for load balancer, you can refer this particular topic, right? It contains more detailed view and also sample codes to tell what should be the structure of the input and output return values of the load balancer, right? That also is given here. So in this particular tutorial, we'll be doing these 4 steps. First, we will build a load balancer custom policy as per the AIOS's required policy structure, and then we'll be testing that policy like unit test to make sure the load balancer that we have created works well, and then we will deploy the policy, right? And then we will be triggering and observing how how this load balancer distributes the incoming request. So these 4 is what we will be checking in this tutorial. Okay, now let's move on to the before actually implementing the policy, let's understand a bit about the AIOS policy system a bit. So we should understand that policies are nothing but it can be a class which will have certain methods as per the policy type that we are using. So the AIOS system has a certain has something called a policy system. It has totally 5 different types of policies: type 1, type 2 till type 5, each responsible for certain kind of policy jobs. So here we'll be using a type 1 policy system, which will actually which will do its execution within the application itself. But in short, policies are nothing but we can have a different policies are nothing but a certain class file with the implementation, and they are pluggable easily, and they can have multiple versions and reusable modules, right? So that across any model block or based on a registry as step towards a discovery. So these kind of things can be achieved based on a certain discovery pattern. Maybe these policies can be detected, and it can be added as part of our life cycle of the block. So if you remember one of our first tutorial, we had something called allocation.json to onboard a new model, and to allocate, basically create that model, create a running instance of the model, which is a block. So here we actually during that time we have shown that the policy, the registration of that block actually had certain set of policies, a chain of policies. So for example, it had something called access checker, which is like a policing system, right? Like we want our blocks to run at certain location only, like we want the block to run only in Calcutta, right? Or we want the block to run at certain zones only, or in certain GPUs only. So those kind of restrictions and things can be achieved in the access checker. Similarly, we also have a cluster allocator where we can tell the we can add a policy or a condition saying that the cluster allocator should work like this, or we can pass the cluster itself, which I will also show in this JSON. And also the resource allocator, we can say that in this cluster we want this particular node and we want to use this many GPUs. So we can control things like that. And similarly, we have a load balancer, which is what this tutorial is about, which distributes the incoming request, right? And a stability checker to monitor the health, and an autoscaler, which was covered in one of the other tutorials as well. So for more details related to the policy system, I request you to check this particular link. It has all the details related to the policies in AIOS ecosystem. It also have the structures like this, the init method, eval, and management functions, and it explains what each type of policies do, and also a detailed explanation about when it is used, which can be used for scaling, and how the scaling is handled for this policy. All the fault tolerance, all those details are given here. Now let's move on to building the actual token based load balancer policy. So in this load balancer, since it's an LLM based model, right, that we are demonstrating, so we are creating a token based load balancer policy, or things can be simply based on some kind of queues or requests per second and all. So and also this tokens per second is a good good proxy for maintaining the cost reasons as well, right? That's one of the reasons also. So we will be fetching some of the live metrics to understand what is the current tokens per second for the models or the replicas. Then based on that, we'll be taking certain decisions. So the core idea is to calculate what is called a load score for each replica based on a weighted average of its input and output tokens per minute. And for the demo purpose, we are keeping it as a per minute, but it's up to us as we have multiple metrics like loading average, just how loading average comes across 1 minute, 5 minutes, 15 minutes. We have this tokens per minute also as across 1 minute, 5 minute, and 15 minutes rolling averages. And then we will give a higher weightage to the output tokens if required, right? If that is a let's say, since LLMs typically take more time to generate output tokens rather than understanding the input tokens, so we can give a higher weightage to the output tokens generation as well. And then we can select the replica with the lowest score, which says that the lowest score is nothing but it is the least loaded replica, right? And then we will also make sure in this load balancer that there is a session stickiness, so that if a particular session is assigned to a certain replica, it will always be used for quick decisions by the load balancer. So with this approach, we hope that, right, we have an intelligent load balancer which distribute the request based on the actual workload in each replica, and then making sure that the overall throughput and latency and the cost things are maintained. So initially, again, don't forget we have certain AIOS v1 policy rule everywhere, which is what we need to mention in our class. So let me start by executing importing the necessary packages. So here I have the init method. Sorry. As you can see here, I have the init method. It contains the output token weight, the input token weight, right? Which is nothing but I'm giving 90% to the output tokens and 10% to the input token, because typically the ratios are that much. Like if the model can process 900 tokens per second, probably its output token per second will be somewhere around 50 to 30 to 50 ranges kind of things. So I'm giving more output weightage here to take the decision. And the average period I'm using is average 1 minute. But like I said, for the demo, I'm using this. We can also have an average of 5 minutes, 15 minutes. And allow random fallback. Like in case for some reason we want to still keep some of the fallback features available in our logics, that also we can do. I will explain where it comes as well. And for the metrics, I'm passing the required metrics here. And we can also get the block data and cluster data via this kind of settings as well. Right, and I'm also creating two state variables so that we can maintain the stickiness of the sessions, and also maintaining a current instances so that we can understand which one to use, which one to assign. Right, so let me run this. And here also we have the another helper function. This is not a required method. This is just a helper function within our main functions of the AIOS type 1 policy. So here what I'm doing is, first of all, from the live metrics, the instance metrics that is passed to this function, I'm fetching the input tokens per minute rolling and output tokens per minute rolling. And in that I'm selecting this average 1 minute's data. This will be a dictionary actually containing 1 minute, 5 minute, 15 minutes averages. Here I'm picking the average 1 minute data. So we'll get the input tokens and the output tokens, and I'm basically multiplying with them with the weight to get a weighted score, which corresponds to the load of the replica. So let me run this as well. Yeah, so here once we have this weighted tokens function, now we can see how the select instance logic is implemented. So here if you can see, like first of all, I'm making sure I have the necessary metrics. And in fact, if there are no current instances, we should always return none, as there is no action to be taken, or there is no weight distribution needs to be happening. So if we have any instances, then we will get the current metrics, and then we will basically call with the required all the necessary metrics. We will call this calculate weighted tokens that we just discussed here, and it will give us a score for each instance. So that score is assigned to this instance scores dictionary in its instance ID. And if in case there is no if we are not allowing any random fallback, this is what I was talking about. If we are allowing a random fallback, and then it will simply go and pick one of the instances, right? But if we are not allowing any random fallback, then it does some logic. So here the logic is nothing but based on the minimum scores of the instances. So we are calculating some scores, and based on the minimum score, whichever has the minimum score, whichever instance has the minimum score, that will be the chosen instance, right? So let me run this method as well. Yeah, now comes the eval method. So this eval method is one of the important, it is part of the AIOS policy rule. So now let's move on to the eval method. So this is one of the prescribed method as per the AIOS's policy system. So this is the method which takes care of calling the necessary inbuilt our other helper functions and all. But this method needs to be implemented with certain rules, like this parameters needs to be passed, and we need to have certain input data and the context. So here from the input data, I will be getting the instances that are currently available for this particular block. And here itself I can decide if the whether so I have this current instances state variable, right? So I can understand whether I still hold the correct set of current instances that are there now, right? So the latest instances, by comparing the latest instances and the current instances, I am understanding two things. One is I need to update my current instances here, right? And also since the instances are already, let's say they are not part of the block now, they are some other instances, and because of autoscaler or some other reasons they have been downed for some reasons, then whichever sessions that were stale sessions that were there for long other time, it was used in the other instances, then I need to clear my history also accordingly. And also I need to clear it from the sticky session variable that I'm having, right? The session's ID cache. So that also is taken care in this particular set of logic. So in case, if there are no current instances at all, then it's simple. We simply will return with a none. There is no instances selected currently, just to make sure there is no other issues. And then what we will do is, then we will do the actual check now. From here on, what happens is, based on the session ID that we get, we'll first check our history variable. If there is already an instance ID or the replica is assigned to that particular session, we'll simply use that as the final instance to be send the request to. So you can see the structure that I'm using, the instance ID colon cached instance. This is the required structure for this load balancer, where it will then the request will be passed to this particular instance. And if in case, let's say that if it is not part of this sticky session, it's a new session, then we need to select an instance. For that, we are calling this particular function again. So select instance is the method that we implemented, right? So based on it again calls weighted tokens method. Based on that and the random fallback variable, it decides the final instance based on a minimum score or of a random fallback. That will be the chosen instance. Now that chosen instance can again be sent to the as a return value. So that's what is happening here, right? The instance ID and the chosen instance. And if for some reason we are in the transition or something, then temporarily we will be sending a none, just to maintain the maintain any breaking of any request. Then even in case of error also, we will send it as a none. And also there is another option here, even in case of an error because of some logic error or something, if we still allow a random fallback, it can still select a random instance, right? So let me run this method now. Yeah, and similarly we also have a management method. So this is again one of the prescribed methods in the AIOS ecosystem. So here you can see some high level, the three high level functions, right? The init method, the eval method, and the management method. So in the management method, it can be a simple health check. Now let's move on to the management method. So the management method is again a part of the AIOS ecosystem. So here these are the three high level. Okay, let me just, in the policy system you can refer this. The three methods that are required for any AIOS V1 policy is init method, eval method, and the management method. So here the management method can have simple tasks like a simple health check, like what are all the current number of instances, right? And if you want current mapping, that can be a method as well. For some reasons, we want these kind of management actions, like administrative actions, right? And but in one more scenario, where if you want to assign streaming, right, for each and every block, and we have to distribute the load also. So at that point, we have to pre-assign a session ID itself. So that's what we are doing here. So in case of a new block getting spun up, that time we will check what is the whether we need to perform any management action, right? So if a new block is spun up, then we will assign the session ID again as a fresh check. We'll first call whatever we did in the select method. It's a bit similar to that. We'll check the latest instances and the current instances, and if there are any stale sessions, we'll remove it. And if there is already that particular session ID is available, then based on the sticky session, we will return it. But if it is not there, right, then we will do the selection of the instance again. So with this in mind, please understand that this will be useful when we are streaming and also handling a load balancing action, right? So then the chosen instance, again, the format and structure are same. The instance ID has to be sent with the chosen instance, and as a default message. If the management action doesn't have the required action, it will send it as unknown action. Okay, now that we have the necessary management function also, let's proceed towards testing this policy. This kind of testings are important because before we deploy this policy in AIOS ecosystem, it helps us, this kind of testing helps us in fixing any issues or like logical issues or any syntax errors and all, right? So this kind of testing is important. And here we are testing two things. One is as a quick mockup, I'm creating a select instance with the lowest score. I'm mocking up some of the metrics data and checking whether it picks up the right instance. And similarly, I also have a session stickiness test, like whether it is correctly retrieving me the same instance for the session already exists. So let me run this now. Yeah, here you can see that it has run, and out of these three instances, it is correctly picking the instance 2 here, right? And similarly, for session stickiness, it is also picking up the right instance. So with this in mind, let's move on to actually deploying the policy. So deploying the policy involves 3 steps. First is we need to assemble the policy in a certain way that the AIOS can understand. And then we need to upload this policy, the policy that we created, as a zip file to a certain location. And then we'll be registering it to the AIOS ecosystem. So we'll go one by one. So first of all, we'll assemble the policy. So like I said earlier, since we are running things in Jupyter Notebook, I'm creating the main class file and also I'm mentioning the main class name and also creating the method under it. But in a single file, we can simply keep things simple, like a single class name and also all the required methods under it. Right, so we'll create a function.py. The name has to be function.py, and we are just I've just copy pasted the same codes that we have created on the top. Okay. Now, and also we need a requirements.txt to tell the AIOS system that it needs to install these requirements to run this policy, right? So let me run this now. So it basically appends this request library to the requirements.txt and shows the code that we have here for function.py. And now we will do a zip of this file. It is important to zip this file with the name that we are using, and we need to note this name as I will show in some time where it is used. Let's run this. It is basically zipping the code folder. I could have probably skipped this unnecessary files, but it's fine for now. And this created zip file I'm uploading to this particular endpoint here. Okay, and since the path is the Jupyter Notebook is running in the same zip file path, I can give dot here, and this is the file name that I was saying about, token load balancer.zip, right? So this will get uploaded here, and we got the message also. Now we are going to register this policy so that the AIOS system understands what it is, right? How it will refer and all. So we can use a simple curl request to this particular using this particular zip file path. But here I'm showing with the request response request library of Python. So here you can see I'm naming this policy as token based LB 1.0 stable, and I'm giving the token load balancer.zip that we passed, and it has to it is currently here, so I'm giving this path. And we also need to pass the schema for this policy. The input schema contains the array, the instances, right, and also the packet and all. And the output schema also has certain structure. Like you can see some of the things here, like the parameters that we are passing, right? The output token weight is a number. It can be between 0 and 1. Similarly, the input token weight, and also for now the default parameters I have kept is 0.9, 0.1 for the output token and input token weight. So this kind of descriptions are also useful because in future any discovery mechanisms can understand what kind of what this policy does and use it for discovery as well. And now we are going to register this policy here, right? And we are basically passing this payload. So let me call this, run this cell. So it is saying the policy created successfully and the success statement is true. So now we have the token load balancer policy as part of the AIOS ecosystem. Okay, and now before we actually use this, let me remind you where this comes in the overall scheme of things for a block's life cycle. If you remember in our during the initial onboarding or allocation of a block, we had something called allocation.json file, right? Let me run this to remind you guys. So here you can see we were using this Gemma block 2, and I'm using the same here. And after keeping the necessary requirements like mentioning the cluster ID and also which GP node to run, if you remember, we also have something called load balancer here, right? So in this load balancer, I'm passing this particular string, which is nothing but what we have registered here, token based LB 1.0 stable, and that's what is given here. So the parameters here I'm giving it as output token weight as 0.75 and input token weight as 0.25, right? And with this setting, we'll see how things are working first. Let me minimize this. Yeah, now we are gonna do an actual implementation of this. Like we will be creating a block with this particular configuration that I showed here, meaning this particular load balancer policy. And let me run this first, then we will see. It will take a few seconds to up it. And since I will also be using KH dashboard to show this demonstration, let me open the KH dashboard here. I'll get the token. So now we have this KH dashboard ready. Here I'll go and select pods and the namespace is blocks. Right, you can see that this Gemma model that we just ran, it has been up for like last 30 seconds ago, and we have the necessary executor here as well. So let me open this. This will have the logs, and this will also have the we can see the logs of the load balances also here. Further, I'll keep it in the block executor, right? Okay, now things are ready here to show. Now let me run this py file. First, it will make sure that there are at least 2 blocks to to do a load balancing. So the already used autoscaler policy is what I'm using here. So let me run this first. Yeah, so this load balancer, I have this code already. You guys can refer it once. So here it is starting each session. It is creating with the 300 input tokens and also 128 output tokens. That's what you have supplied here. So let me show the logs to you guys. Yeah, here you guys can see that initially, since there is only one instance, the scoring is happening for only one instance, right? And the request is getting routed to it. Also, we will see whether it has scaled or not. I'm just opening more tabs to know whether it has created another block. And just to sustain the load, I will also run another request here. Yeah, now you guys can see the autoscaler also has come into action. It has created another instance. Now we can see the logs of our load balancer. Yeah, here you guys can see, right? So initially there was only one particular instance. Now since the replica has created, since the autoscaler has created another replica, now the requests are being directed to this particular you can see the chosen instance with the lowest score is this particular 9LJD instance, right? So the requests are routed to it. Later again, once if the scores are same, then again based on the weightage of the load, the correct particular instance is selected. So here you can see again it has selected this. And just for reference, we have two instances. Again, to maintain the load, let me keep running this. So let me show both the instances. So you can see one is in 9LJD, another is in IPTB. So that is what we are seeing here, in 9LJD and in IPTB, and the requests are routed to the correct instances as per the load. So to see the logs, I can show this logs also. Right, you guys can see, I think, like, we are receiving requests to this particular instance also as per the load, and in another instance also we'll be getting the similar inferences here. Right, here also the inferences are happening. You guys can see I'm giving next, and the next request informations are loading. So this is how a typical load balancer can be implemented in the AIOS ecosystem, and this will help us in making sure that we are utilizing the resources in the right way, in an optimized way, and I hope you guys will be encouraged to try more of these custom policies yourself, and in this way we can have more hands-on on using the AIOS's policy mechanisms as well. Right. See you in next tutorial. Thank you.